In today's video, we're going to be learning about ballistics. So a little bit of history for you. So the Chinese were the first to invent gunpowder and did so over 1,000 years ago. Now they were primarily using it in a firework kind of capacity, but they were the first to invent this explosive powder. The first real guns, so to speak, were muzzle-loading matchlocks, which use wicks to ignite the gunpowder. They were called muzzle-loading because you load them from the front, the muzzle of the gun. So you essentially packed gunpowder in there, put the bullet in there, packed that in there, and then you stuck a wick in the back of the gun like a candle wick and lit it on fire, and then you held your gun straight forward and waited for the wick to burn down and ignite the gunpowder. You've probably seen this if you're a history buff and have watched, like Revolutionary War movies. You have seen them doing something like this. Now, the problem with this is you had no control over when the gun was actually going to fire. And if the wick went out, you didn't know that your gun wasn't going to fire. So this was not ideal. So then we invented cartridge and breech loading. So a cartridge is where you have the gunpowder and the bullet all together. So we no longer had to pack everything in as a separate step. And breech loading is where you can load this cartridge from the back side of the gun. We then added rifling to guns to provide greater accuracy. We're going to talk more about rifling in a little bit, but essentially it allowed our bullets to go where we were aiming them much more effectively. And since then, there have been a ton of developments in guns, from revolvers to semi-automatic to automatic guns have all been developed. Guns are a huge field. So from a forensics perspective, ballistics helps explain what type of firearm was used, the caliber of the bullet, the number of bullets fired, where the shooter was, whether a weapon was fired recently, and if a firearm was used in previous crimes. So these are all important elements when it comes to solving and prosecuting crimes. So the barrel of a gun, and that's what this picture up here is showing, the barrel of the gun is divided into lands and grooves. These are created during the rifling process. And a land is an area of the rifling that slightly sticks out, while a groove is grooved. It is an inward portion of the barrel. Now, as we said, rifling was added for greater accuracy. So how rifling works is that typically a mechanical object is jammed down the barrel of a gun in a spiral fashion and then pulled back out, creating this rifling. Now, that means when a bullet is fired from a gun, it goes down the barrel, and that's going to leave land impressions, which are actually going to be stuck into the bullet slightly because they were stuck out in the barrel, and groove impressions, which are going to stick out slightly on the bullet because that was a sunken area in the barrel. Now, on my picture, you can see that they're rather big, but in reality, these are pretty small. So rifling is what causes a bullet to spin in a spiral. So like throwing a football in a nice tight spiral goes where it is where we want it to go a lot better. The same is true with bullets. Because of spiraling, the bullet is going to follow those lands and grooves through the barrel, creating a spiral. That's going to make it spin when fired, so it is going to have greater accuracy and be more likely to hit its target. So one of the big terms in ballistics is caliber. And caliber is a measure of the diameter of the cartridge. So not the bullet, the cartridge. Now, these are typically measured in hundredths of an inch. We would use rulers or calipers to determine the caliber. Now, typically, you do not hear people add the hundredths of an inch when they are talking about calipers. You'll just hear them say, oh, it's a 22, it's a 25, it's a 357, 38, 44, 45. And that's because it is understood within the ballistics community that we are talking about hundredths of an inch. Now, not all firearms use cartridges that are measured in 1/100th of an inch. Some cartridges and guns, therefore, use millimeter cartridges. Two common ones are the 9mm and the 10mm, but you notice how when you say those, you do include millimeter because that's different than the norm. Since hundredths of an inch is the norm, it is kind of not quite policy, but common practice to not say the measurement because everyone just knows. But if it's outside that common practice, we would say millimeter to let someone know that we aren't talking about 9/100ths of an inch. And so this is going to, so keep in mind the diameter is from side to side on the bottom, so we can just take that ruler or calipers and measure across the bottom to get that caliper. So I mentioned before that cartridges are kind of a one-stop shop for what we can put into a gun. So how they are set up is the cartridge is going to be at the bottom, and it is going to contain the primer and our propellant, typically gunpowder, and then it is going to have the bullet stuck into the top. Now it's pretty firmly in there, not like impossible to get out, obviously, because we want the bullet to fire, but it is stuck pretty good in there. So now we have everything all together. So for those of you not so familiar with firearms, how do they actually work? So when you actually pull the trigger of a gun, the firing pin is a part of the gun that is activated by the trigger. The firing pin swings forward with a large amount of force. So much force it actually dents the cartridge. The cartridge is the bottom, remember? And the firing pin is going to hit the base of the cartridge right where we saw that primer on the previous slide. This amount of force generates a small amount of heat, which ignites that primer powder. Primer powder is much more explosive than gunpowder, so it is very easily activated. Then that primer powder is going to create a spark that goes through what we call the flash hole to the main propellant supply. The main propellant supply being whatever our gunpowder is. That's going to ignite the gunpowder, which is less explosive than the primer, but still very explosive. And it's going to cause the gunpowder to expand to 6 times its size. Now, this is all happening inside a cartridge, inside a metal gun. So this is a lot of pressure that is now building up that has nowhere to go except forward, because the only opening on the gun is in the barrel, out of the gun. So the pressure of the explosion pushes that bullet out of the cartridge. So the cartridge is getting left behind, and it pushes the bullet into the barrel. So out of the cartridge into the barrel. And as that pressure continues chasing the bullet down the gun, the bullet starts following all those lands and grooves and comes spiraling out of the gun towards its destination. Now, once a bullet has been fired, from a forensics perspective, we can do a lot with it. We can look for both class and individual characteristics. So bullets can have class characteristics, meaning they're not individual to that bullet alone and could meet other ones because different gun manufacturers use different rifling techniques. Some of the differences you see between gun manufacturers are the number of lands and grooves. Some use more, some use less. The width of those lands and grooves. Some gun manufacturers use wider ones versus smaller ones. The depth of those lands and grooves. Some gun manufacturers use thick ones while some use thin ones. Also rotational directions of pitch, yaw, and spin, which are going to determine exactly how that rifling is done, is going to determine the exact kind of spiral of that bullet. Now keep in mind these are all class characteristics. So all bullets fired from a gun of that same variety would have all of these characteristics in common. However, when a bullet has been fired from a gun, it does possess individual characteristics at that point. Now, not individual to a person, but individual to that gun. So a cross-section of a gun barrel will show small grooves or striations along the lands and grooves. So even though in a lot of guns are machine manufactured, you would think they would be all the same. But as that machine rifles each of the guns, it is slowly getting slightly worn away, meaning it is going to affect each subsequent gun slightly different every time it does it. Therefore, those striations that it leaves inside the barrel of the gun are unique to that gun and only that gun. No two guns have the exact same markings, even if they were done one right after the other. There will be microscopic differences between the two, and those microscopic differences are imparted onto the fired bullet. Let me show you what I'm talking about. So once a bullet has been fired, it gets these striations onto the bullet. So those are the lands and grooves, but those are also some microscopic striations because those lands and grooves are slightly different each time. So we can look at them under a comparison microscope, and you can see these two bullets are a match to each other because their striations line up exactly. Versus these two bullets are not a match because despite our best effort, these striations do not match up. So this is an individual characteristic. Now, cartridge cases, what is being left in the back of the gun after the bullet has been fired, can also have class and individual characteristics. So some class characteristics of cartridges are the manufacturer. This is normally stamped on the bottom of the cartridge, such as Winchester. The shape of the cartridge. Different guns take different shaped cartridges, like rimless or rimmed. The caliber of the cartridge. Different guns take different calibers. For example, 12 gauge, that is a shotgun caliber versus 9mm is a handgun. So different guns do take different calibers as well as composition. Cartridges can be made of different things from brass, steel, even plastic. So those are class characteristics. They would get us to a general type of cartridge, but not anything specific to one gun and only one gun. However, cartridge cases can also have individual characteristics once the gun has been fired. Even though the cartridge is being left behind, that cartridge has to be cleared before the gun can fire again. Now, some guns clear automatically. We call those automatics. Other guns, you have to manually clear that cartridge. But the cartridge can have firing pin impressions, breech face marks, ejector marks, or extractor marks. And you can see those different things located on the gun here. Those are individual characteristics left on that cartridge. So we don't see those until after the gun has been fired, but they can be matched to one single gun. So when we're talking about the breech is the very bottom of the cartridge, so it looks circular. And there are many different types of breech face marks, but here's six that you need to know. We have heavy left side, where we can see we get a lot of marking from the breech on the left side. Vertical, where we get these vertical lines from the breech. Sandblasted, where you get all these kind of dots. Mottled, which is sort of like vertical and sandblasted had a baby. Rim dents, where the breech actually dents into the rim of the cartridge. And my personal favorite, mouse ears, where it leaves these little semicircles, making it look like everybody's favorite cartoon mouse. Now, firing pin marks are made when the firing pin hits into the breech, the bottom of the cartridge. So in order to fire the cartridge, the primer must be ignited. We do this through the firing pin hitting that cartridge. We already talked about that. What we didn't talk about, though, is the firing pin is going to leave a distinct impression that is unique to the firing pin of that gun and only that gun. Here's an example picture showing you what I'm talking about. So these are two different cartridges. You can see the line down the center. This is the firing pin mark that was left in the bottom of the cartridge. We are able to line up these two cartridges and show that they were made by the same gun because even the striations left by the firing pin are identical to each other. Once again, this is individual and would only match to one gun. Additionally, I mentioned that the extracting pin and ejector can also leave marks. What they're responsible for is they throw the spent shell casing from the chamber of the gun. Once again, this may be automatic, this may be manual, it depends on the type of gun. And they leave marks on the shell casing, so this is the side of the cartridge, that are unique to that gun and only that gun. Some general patterns that we can see are curved, diagonal, spiral, dirt flow chamber marks where it kind of looks like the chamber was dirty, light ramp bulging. This is actually a clipping into the cartridge itself. Heavy ramp bulging, which is a much deeper clip in, or thin chamber marks, which are kind of like dirt flow plus spiral mixed together. Once again, there are many more than this. And these are just general categories. On a microscopic level, two diagonals, if they were fired from different guns, would not look the same. So, like we saw, we can look at these microscopically to tell them apart from each other. Now, something else having to do with ballistics is gunshot residue, often called GSR. So particles of unburned powder and traces of smoke are the residue of gunshots. So when that bullet comes out of the end of the gun, with all of that pressure from the exploding gunpowder chasing it, oftentimes unburned powder makes its way out the barrel of the gun as well. So this can leave traces on the hand, arm, face, and hair and clothing of the shooter. So the shooter is the one holding the gun. They are very close to it. They are going to get GSR on them. Depending on how close they are to the victim may also get GSR on them. Now, we use chemical testing to detect the residue of gunshot residue. And these chemical tests are very sensitive and can test for GSR even if someone has tried to wash their hands, take a shower, etc. The issue with this chemical testing is it does not tell us how long the GSR has been there. So, for example, if someone goes to the shooting range frequently, they are probably always going to have a low level of GSR on them. And that might make it difficult to prove that they recently fired a gun versus a few days ago at the gun range. So it is not a completely accurate test in terms of knowing when it happened. Now, something that is helpful, though, is we can determine the distance the victim to the shooter by evaluating that residue pattern. The more gunshot residue a victim has on them, and the more concentrated it is to one location, means that the victim was closer, versus the more spread out that residue is going to mean that they were farther away, and they're also going to get progressively less on them the farther away they get. So this can give us a good idea of where the shooter was in relation to the victim. Now, this brings us to something that's very important when it comes to ballistics, and that's calculating bullet trajectory. So trajectory is the path that a bullet takes to its target. Now, we need two reference points to define a trajectory, and investigators can figure the shooter discharged the firearm somewhere in that area. So when it comes to picking those reference points, bullet holes are going to be an excellent reference point. This can be in objects or victims. This is going to get us an angle that the bullet entered at. The entry and exit point of a victim can also be used. We can also use gunshot residue or spent cartridge casings, because remember, cartridge casings don't fly forward out of the gun. They are ejected from the location that the gun was at. So they are often very near to where the shooter was standing. These can be less specific reference points. Investigators can also use lasers to trace a straight line path to help determine the exact position that the shooter was from. So as far as how we calculate, it is height of the shooter equals the tangent with the angle of elevation times the distance to where we think the shooter likely was. Now, you may need to add feet from the ground to get the exact height of the shooter, depending on the exact scenario. So a sample question for you. A bullet entered a window at a 35-degree angle. So we would have measured the angle in the bullet hole in the window. The shooter was 15 feet away. Maybe we figured this from cartridge casings, maybe gunshot residue, but we figured out how far away approximately they were. Now, in our window, the bullet hole was 7 feet from the ground. So we are going to do the tangent of 35, tangent of angle, times where the shooter was located, so times 18. That gets us 12.6, but then we have to add the height, that's 7 feet. So we know that they were approximately 19.6 feet above the ground when they made this shot. So this tells us this was not someone standing on the ground. This was likely someone in a building or on a roof making this shot. Now, last thing we need to talk about are bullet wounds. Oftentimes, if there is a shooting, that means someone got shot. Now, one thing people a lot of times don't think about is most victims end up with 2 bullet holes, an entrance wound and an exit wound. It is important for us to determine which is the entrance and which is the exit. Now, usually entrance wounds are smaller than exit wounds. This just has to do with physics. When a bullet enters someone, it is usually in that tight spiral caused by the rifling, meaning it's going to leave a small hole. However, as it enters the body and hits that tissue and muscle and bone, that spiral gets substantially disturbed, meaning if the bullet does exit, it is going to no longer be in that nice tight spiral, meaning it's going to leave a bigger hole. Additionally, we can use fiber evidence and gunshot residue to determine entrance versus exit wounds. Entrance wounds are more likely to have GSR on them than exit wounds. Additionally, entrance wounds are more likely to have fiber in them than exit wounds are. Bullets may go all the way through, called a through and through, or they can become stuck in the body. This largely depends on the speed and caliber of the bullet. Some bullets are designed to go through things better than others. Also, smaller calibers of bullets are more likely to get stuck than larger calibers of bullets. Now, question students always ask is, can police require a bullet to be removed from someone? And the truth is they can't. It is up to a doctor if a bullet becomes stuck in someone to determine whether it's in that patient's best interest to have the bullet removed. Sometimes for health reasons, they need to remove the bullet because it's causing problems. However, a doctor can say that that bullet is perfectly safe where it is, and it would be more damaging to the victim to remove that bullet, in which case the bullet has to stay inside of them, and there's nothing that the police or crime scene investigators can do about it. So that's what we got for ballistics. We're going to spend the next couple days practicing with everything you learned.